check with your advisors because engineering programs are pretty tight, as far as the courses go. So, taking a semester off is probably what would end up happening because unless you go to an engineering specific thing. And also, I would remind you that there are other opportunities besides studying abroad to travel abroad with others, including Engineers Without Borders. So check them out because I do know that the civil engineering folks, they take folks on Engineer Without Borders trips every year or so. So I don't know how applicable that is to computer engineering, but it is a possibility. So today we're talking about something a little bit different here. Now, normally when I do this up in Lincoln, down in Lincoln, I've got some representatives from the Writing Center, and the UNO does have a Writing Center that you can go to. It's not on the PKI campus, it's up on the main campus. But I've never been able to get somebody to come and help me out with it, so I'm flying solo today. Anyway, these are, what we're going to talk about is how writing code and designing code is basically paralleled with how you write stuff, right? Because ultimately we're going to focus on technical writing, and so how do you go about technical writing? In a lot of ways, it's like writing documentation, like when you're writing code and you're placing documentation with it. This is an infographic from several years ago, but I'm sure that it has not changed. Where we've got industry folks that are saying that these are essential aspects of new hires, which, by the way, 1 week from today, you're going to be having a job fair out here in PKI. So if you have time, make sure that you come early so that you can spend some time there, or I think it ends during our lab, so you want to come here early and check out some of the employers. And you can ask them about this stuff, because one of the things that they identify as absolutely important is oral and written communication. But at the same time, they downgrade their new job applicants, or they rate their new hires as very low proficiency in that, right? And so that is a way that you can set yourself apart from other applicants in a lot of job applications if you just have some simple good oral and written communication skills. The number of people that can't put together a coherent email is staggering. And if you look at not just college people, but the population at large, the number of people that don't even read at a 6th grade level in this country is staggering. It's a really stunted country as far as education goes. So today we're going to actually look at two techniques, writing techniques that I was taught by the Writing Center when we put this together several years ago. And one's called free writing and the other is called reverse outlining. And then we're going to talk about the actual design document that your first draft is due this Friday. Free writing is, if you've ever taken an art class, I've never taken an art class, but there's something called free drawing, right? Where you just put the pencil down, you don't pick it up, and you just start scribbling until you get an idea, and then it starts taking form. Same idea with free writing. Basically what you do is you just have to get started. So let's just start writing something. I have to write this essay, or I have to write this short story, or I have to write this technical design document. So what you do is you just start spitting out ideas. We call it brainstorming, right? But basically you just start writing, right? And so the prompt that we're going to give you are, what are the steps that you take to get from an idea to a final draft when you're doing something, right? And it doesn't matter if it's a poem or if it's a technical design document. And then how are these steps similar to your coding process? Okay. So we are going to take 4 minutes here to just go ahead, pull out a piece of paper, or pull out your phone, or pull out your computer and just start typing to answer these two questions. And I'll give you about 4 minutes. And again, there's no right or wrong here. Ultimately, what you're going to do is you're probably going to throw away most of what you write. The point is to just start writing, a stream of consciousness. Even if it doesn't directly answer these questions, just start writing. I have no idea what I'm doing. I have no idea what I'm doing. Okay, now I've got an idea, and start writing that. right, I'll go ahead and stop you right there. So, does anybody want to share a thought? What are the steps that you take to get from an idea to the final draft? Not one idea? Yeah.
Just truly thinking about your idea before you even write anything, just like making a mental outline of things.
Mental outline of things. Or to parallel that in code, right? You'd whiteboard an idea, right? Spitball an idea up there of diagram something or something like that before you start coding, before you start writing code. Yeah, another one? Breaking it up into parts. So that's the top-down kind of thing from CS1, where you break it up into parts until you've got these small parts, and then you can directly do those things. Or in our case, we want bottom-up. We're going to start thinking about our object design first. Right? So this is a great technique that you can apply even to code, because the most common issue that students come to me with is, I don't know how to get started. Right? This is how you get started. Right? You just start spitballing ideas. You could spitball, you could like do this for 5 minutes and come out with 10 lines of code or 10 lines of text or whatever, and 9 of them suck, but it's that 10th line that's what gets you started, right? And not unknowing, it's never true that you don't know how to get started. It is 9 times out of 10, it's a fear of not being able to complete something, rather than that's what's stunting you from getting started. And so you just need to push yourself into gear to get started and do that first step, right? And so free writing or brainstorming is an excellent idea, excellent technique to get you over that hump. With reverse outlines, it's actually at the end. So you've written something already, right? And what you want to do is you want to determine, what I wrote, was that any good, right? And so what you do is you start with a complete draft, then you summarize each function of each paragraph, right? And then you number your paragraphs, okay? So here's a well-written cover letter that a colleague, the person that helped me put this together, they were writing because they were searching for a job. And so the first paragraph here is, I am writing with great enthusiasm to apply for your position of the Learning Commons Supervisor at Cuyahoga Community College. I'm currently the Associate Director of the UNL Writing Center, period. All right, so what is the purpose of that sentence? Summarize it. We're going to reverse outline it. Number 1, what is it? What's the purpose of that paragraph? What is she doing?
Stating her, like, who she is.
Introduction and what her, I'd say more her purpose. If we jump ahead here to the second paragraph, that's probably why she's explaining, she's at these 7 years of tutoring, 20 undergraduate supervisors, 20 undergraduate and graduate tutors, etc. Right? Now, what if this were not well written? Right? It would have been very difficult to reverse outline this. Now, or redundancies would have come up. If I had 2 paragraphs and I outlined them with the same thing, I'm introducing myself. Right? That's a huge red flag. That what should I do to those 2 paragraphs? Probably edit it and collapse them together, right? Or combine them together in something. Or if I'm doing one thing in the paragraph up here and the exact same thing down here, maybe it's okay for iteration, right? Usually you do that, there's the good, the bad, the good, right? You state something good, you state something bad, but then to recover you state something good, and it could be a reiteration of what you just said. So what we're going to do is we're going to try doing that with code. Can we reverse outline code? So here's an exercise that we've actually given many years ago in this course. What we're going to do is we're going to generate what's called a suffix array. So we're going to start with a word, or you can have an entire string of characters or a phrase or something like that. The suffixes are the last word. So for example, the suffixes, the word itself is a suffix. And then if you take off the first letter, right, then that's a suffix. If you take off the next letter, that's a suffix, and so forth, until you get down to the last letter here. Then what you do is you sort them in lexicographic order. This has a lot of applications to fast index lookups and searches and DNA analysis and a bunch of other things. Right? So here's some code that does solve this problem, that generates a suffix array. What I want you to do is reverse outline this one. Right? I'll start by asking anybody here, how many bullet points do you want? Or how many numberings do you want? What's your instinct? Just the first thing that how many numbers should I outline? No? Three? Okay. Why did you didn't even have to read the code to see 3? Why?
Just the white space.
The white space. That's called chunking. When you chunk your code, you're chunking ideas, right? And vertical white space gives you that kind of chunking, right? That there's something going on up here, even though it's multiple lines, they're probably all related somehow. There's something going on here, and then the separator there's something else going on here, right? So I would agree, 3. Now let's focus on this first chunk here. What is it doing?
Establishing the string and then making an iteration over your argument.
So it's creating all of the suffixes and putting them into this list of suffixes here, list of strings, right? And you could break that down into 2 parts, right? It could be that you initialize the list and then you populate the list, okay? What about the second chunk right here? What is it doing? It's sorting it, right? That's obvious because you're calling the collections.sort algorithm, right? What about the third one right here? What are you doing? System.out is, you're printing them, right? So there's the reverse outline of the code. It was well-written code. It was easy to reverse outline. There. As another solution that does the exact same thing. It is correct syntactically. It will produce the same output. Is that going to be easy? No. In fact, we wouldn't want you to do something like that. It would be difficult to reverse outline, which tells you what? It's badly written code. Just like a or a difficult to outline letter or essay or whatever is badly written letters or essays, right? You tell me though, what are some things that you see here that make this bad code? Start with that first line. Why is that bad code? IJK, are those good variable names? No, unless they're scoped down to an index variable in a loop. Not only that, but do you see K used anywhere else in the entire program? No. So unused variables, bad variable names. In fact, down here, temp2, those good variable names? No, they don't say what's their purpose. They're declared there, right here, but where are they used? I'd have to jump around. I don't even see, oh, okay, that's used right here just to swap something or something, right? What about this chunk of code right here? Is it good code? What does it do? Yeah, you're going to take a couple minutes to realize that it doesn't do anything, right? Why is it even there? What do we call that? Cruft, right? In fact, there's cruft up here. Right? Somebody was obviously trying to do some debugging, and they left this code right here, this commented out code. They were trying to do it interactively, right, as a first solution, and then realized that they needed to use command line arguments. So they left that dead code in there. Clean up your cruft. But this code essentially doesn't do anything, right? Especially when you repopulate the suffix array down here. And how are you doing it? Character by character by character, right? So inefficient code right here in this chunk right here. Right? Does anybody know what this is doing right here? Maybe, maybe not, depending on whether or not you covered searching and sorting in CS1. This is selection sort, right? They rolled their own sorting algorithm. It is sorting the array, the suffix array right here, but it's not using, say, a built-in sort method like this. Which one are you going to write? This one line of code here that takes care of it for you, or are you going to roll your own terrible sorting algorithm? And selection sort is a terrible sorting algorithm, right? And then finally you have the results down here, but it's way overly complex because they're not calling system.out.println. They're creating this one big giant string with endline characters just so that they can print it once at the end. Right? So no, terrible code. And by the way, this was the 3 worst submissions that year. This is like 6 years ago or so. But these were the 3 worst submissions all combined together. Right? I took the worst aspects of each one of them and put them all together. So it wasn't just, it took 3 people to make code this bad. Right? Right. So, so we've got a technique to get you started, free writing. We've got a technique to see if what you've written is correct or not, right? Or what you've written is well organized. You're going to be doing a design document throughout this entire semester. With your first draft due this Friday at midnight. Okay. So my first question is, what are you writing? Who is it for, and why is it important? Right? Now, if you've looked ahead, you might know the answer to these questions. But my question to you is, where do you find these the answers to these questions? Where do I get started? The handout, exactly. And in the handout, right, that's available in Canvas and on GitHub, there at the very top, the second or first paragraph, whichever one it is, the design document should be, quote, clear and comprehensive enough that a reasonably technically competent person could reproduce your system through, though not necessarily every detail, with identical functionality without access to your actual code base. You are writing this for another technical audience. You don't need to explain that system.out.println prints the lines of the standard console, right? You can assume a level of technical competence equal to your own, right? So you shouldn't be going over the minutia. What you should be, you should also not be going over the actual code, right? Here's my code. I chose to use an int instead of a double for whatever reason. Right? No, that's not. This is much higher level, right? They need to be able to reproduce your system design. In other words, they should be able to read this document. You're writing it in Java and SQL. They should be able to read this document and reproduce it in, say, C# and Postgres or a SQL server, right? In other words, completely different technology, but the same functionality, okay? That's the higher level abstraction that you need to be writing in and for, right? So why is it important? 2 reasons for the class, as far as the class goes. In real life, design documents are important because you hand them off to a development team. They use those design documents to actually write the software. And then when they're in compliance with the design document is supposedly in compliance with the requirements document because there are contracts, legal negotiations, right? And if your code is conformant to the design document, you're in the clear. If the design document is conformant with the requirements document, they're in the clear. If the requirements document is not what the client wanted, then it's the client's fault, right? And they still pay you, right? And there are legal issues here that when you work at a company, they're going to have contracts out, or it's even more important if you ever are a freelancer, an independent contractor, because then you need to also be your own lawyer a little bit and write those contracts. But it's whether or not they pay for the product that you produce, right? And nope, you signed off on it, it's yours, pay us, whether or not it's what you wanted, right? In fact, on my CS1 course, towards the end of the semester, I have a suggested watching. There's an excellent video series, it's just a video lecture on, it was not technical, folks, it was actually a design firm for graphic design, along with his lawyer, talking about if you are ever in a position where you have to freelance or you're your own independent contractor, you need a lawyer. It is 10 times, the amount that you spend on a lawyer is 10 times what they're worth, right? And the video is awesome because they go into all these details and it's provocatively named "F you, pay me," right? And it's a really great video. I suggest that you watch it at some point. But that's whether or not you're ever going to be an independent contractor. Anyway, as far as this course goes, there are 2 important reasons. One, we're giving you experience to technical writing, right? For using technical writing and doing technical writing. That's part of the College of Engineering's, what is it called? The complete engineer, right? It goes all the way back to that first slide where technical communication is an absolute essential skill that most people don't have. I like to give people, freshmen mostly in here, exposure to that skill. The second one is you're going to be turning it in on this Friday when your first phase, assignment number 1, is due the next Friday. In other words, we're going to be giving you feedback on your design 1 week ahead of time so that you can head off any problems. Or that's not good. You give us a design and we're going to critique that design and say that's a good design, go with that. That's a bad design for these reasons, or you want to avoid this or you want to do that instead. Right? If you do not give us that kind of detail in your design document, in your draft, we're not going to be able to give you that kind of feedback. Right? So what are the draft 1 expectations, and where could you start to answer that question? What are we expecting in that first draft? Maybe the handout, but this is a separate question, so there's a separate answer. No? Campus wire. So let's come back over here. Right? Remember that I pin assignment posts for every assignment. What you should be doing. For example, on assignment 0, I gave periodic updates of this is where you should be by this point. And if you're not at that point, I followed the Gantt chart. If you're not at that point, you're probably behind. Or if you are at this point, you're probably on track or you're ahead or something. Right? So what should you be doing today, like yesterday and today? You should be reading the project overview. You should be reading assignment 1, right? The project overview is going to be for the project for the next 12 weeks. No, you don't have to understand it all. No, you don't have to implement the entire thing 12 weeks into one week or one phase. But you have to have an idea of what the bigger picture is for the project. Assignment 1 focuses on EDI, that's electronic data interchange. And so you're going to be designing your objects and you're going to be reading them in from CSV files and dumping them out to JSON or XML. That doing both is worth bonus, by the way, right? And you will be using libraries to do it so that you don't have to write so much code. Right? And then finally, the design document expectations. Right? If you are working in pairs, you need to team up in Canvas now. The instructions on how to do that are in the project overview. You also need to be setting up your project in Eclipse. We give an entire video on how to do that. Exactly. Follow those instructions exactly. Because you will be turning in what's called a jar file. It shows you how to build it, shows you how to turn it in. Right? You should be planning the next 2 weeks, right? Minus these 2 days. I'm going to be doing this on this day. Follow along the Gantt chart or modify the Gantt chart so that you are working at pace. Right? We'll talk about this towards the end of the semester, but the way that I've organized this course is using Agile, Scrum, right? So when you get into industry, you might use Agile, but basically it's you have periods that are called sprints. Usually it's about 4 weeks. For us, it's 2 weeks, right? Because we've got a semester here. But every 4 weeks, what happens at the beginning of that 4 weeks, you and your team, it's a self-managed software development life cycle kind of thing. You and your team look at what needs to be done and you commit to all these things, right? And you say it's reasonable for us to get all this stuff done in 4 weeks, right? That 4 weeks, it's locked. You can't have a manager or a pointy-haired manager or incompetent idiot come in and say, nope, drop everything. We've got you this other project we need you to do. That's not how it works, right? Go ahead and put that on our backlog. At the end of the 4 weeks, if you want to prioritize that, then we'll go ahead and do that in the next 4 weeks, right? It's designed to make sure that you know what you're doing at all times, that you have some agency in your commitment at the front, and some accountability for it at the end. Because if you committed to all these things and you didn't get it done, you got to assess why didn't we get it done, right? And it's also used as an organizational tool because what you do during that sprint, that 4 weeks or us 2 weeks, is you have this called this burn down chart. A perfect burn down chart would look something like this. You've got all this work at the beginning, here's at the end, and it's a nice straight line. That means that you've been working at the same pace throughout that entire 4 weeks, right? If you had a burn down chart that looked like this, right? It immediately went down, right? You got everything done on the first day, right? Awesome, but you probably burnt yourself out doing that, right? Or if you had a burn down chart that looked like this, we're not making any progress. We're not making any progress because we are procrastinating until we get down to the end of the day, and then what? We try to get everything done, and that's not going to work, right? It doesn't work in a class. It doesn't work in the real world, right? So you should be planning for that, right? That I'm going to be doing this on this day. I'm going to be doing that on that day, etc. Right? The actual design document expectations here are going to be your template. Does anybody know LaTeX? All right, then you'll want to use the word template. We provide a Word template, and you need to use it. Put your names on it if you're teaming up, both of your names, one copy. And then you'll also adapt it for this semester. There are a bunch of placeholders in there showing you how to do things, like there's a bibliography with fake citations and stuff. You're going to want to take those out or adapt them to your purposes. We're expecting a fairly good introduction, section 1. That proves that you've read this handout up here. Who's the client? What is their business? Right? What are their business rules? What are you writing, doing in this project, etc. Right? That's the introduction. We're expecting an initial class design. Right? That's section 3.2 for phase 1. What classes will you design, implement, and what are their member variables and methods? Right? Kind of like what we've been doing for the last 2 weeks with books, people, isotopes. Right? And who is responsible for what functionality? Right? How do you plan to test? Right? You're going to write your own test cases because that's also part of that phase. And by the way, look at the rubric, because one of the bonus items is turning in that test case 1 week early. We'll grab that and use it for testing for everybody else. And so if you, again, it's optional, but if you generate that test case 1 week early and hand it in, then we'll give you an extra 10 points. Right? And by the way, generating a test case in this case, read the handout, it's not that hard. You just have to go to mockaroo.com and generate some data. Right? Not a lot of data. Right? We don't want a lot of data. Right? Otherwise, you'll submit it as a PDF through Canvas ultimately by Friday night. Right? And then we'll give as much feedback as we can over the weekend. It's just me for this section. And then you'll be able to look at that feedback and incorporate it into your actual project. I mentioned a UML sketch here. Sketch, emphasis on the sketch, right? Let's take a look. We'll come back to that. Remind me of that, okay? But there's also a professional example here of a design document from Deloitte. They're a pretty large software development firm for hire, and they've got a lot of folks. They get a lot of government contracts, and so if you want to see what a professional example looks like, it's here. Doesn't necessarily mean that you have to follow it or that you should follow it, but here's an example page from that professional example. Why is that good technical writing? So does this look like a page from a novel? No. A page from a novel would look like what? Text, 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 paragraph, paragraph, paragraph. Is that what this is? Nope. In fact, it's organized into sections, right? Sections are numbered. And instead of paragraph or walls of text, what have we done in section 2.1 here? We bullet point lists, right? Bullet point lists are your friends, right? Not only that, but take a look at those bullet points. How are they written? Very dry, very direct. Right? Requirements phase, during the requirements phase, blah, blah, blah. System design phase, during the system design phase, blah, blah, blah. Right? Repetition, right? This is not something you read for fun, right? And you're not writing it for fun either. You are writing it to convey information. You want to be terse, right? You want to be short, right? You don't want, if you're trying to think of, I've used this word too much. No, that's fine. That's perfectly fine, right? I need to pull out my thesaurus and find another word for cool. No, use correct language, right? Okay. Here's another page from that design document. Is there much text here at all? In fact, for the entire section, how much text is there? One sentence. Look at the figure. A technically minded person would be able to look at this and immediately see that it's an ER diagram. By the end of the semester, you will be too, because you're going to be generated an ER diagram. That's an entity relation diagram. This is the database, right? Each one of these is a table, and each one of these describes what's in the table. These arrows describe the relationships between the tables, okay? We'll cover that much later on, but as far as technical writing goes, if a picture is worth 1,000 words, a diagram is worth 10,000. If I actually had to describe this in words, I'd be writing 3, 4, 5 pages of text, right? Whereas it's one generated image right here, one generated figure, okay? There's the UNL Writing Center. I don't have any information about the UNL Writing Center, unfortunately, but you can go ahead and Google it, right? So that was kind of a UML diagram. It was an entity. It was a special kind of UML diagram. It was an entity relation diagram. Well, we're not expecting database stuff here on your first draft. Instead, we're expecting class stuff, code stuff. So let me come over here to Eclipse and show you what a UML diagram looks like, but we don't expect you to generate yet. Right? So remember our book and our person class? I'm going to go ahead and highlight those and show you what a UML diagram looks like of those. Right? So here's the book class. What are its member variables? Those right there. What are its member methods? Those right there. Right? In fact, you could, if I were to sketch this out instead, I would just say getters, comma, no setters, right? If I were to whiteboard this, right? But I would definitely go into detail on all of the member variables here. There are some visual cues. For example, the red means that it is private. Why is title public? That's weird. Let's go over here to book. Did I really make it public? I did. I don't know why I did that. Let's go ahead and change that. Did you see the visual cue there? It changed to red. Okay. That's because it is now private. These are all mutable, and so I believe that that's why they're called they're opening. So if I did this final. Nope, that's not a visual cue. I'm not sure. I'm not sure what the filled in versus the non-filled in is. I forget. But squares for member variables, circles for member methods. You don't have to get technical like that for your first draft. Remember, it's a draft, right? We want to know what classes you will design, implement, what are their member variables, and what are their methods. If you were to put that, even on a piece of paper, if you were to sketch that out, then throw it into your PDF document by taking a picture of it or something, that's what we're looking for. Right? Eventually, after you've written your code, you'll use a tool like Plant UML here to then diagram your entire project, right? Something like that. Right? That's not very good because I've got book and I've got author here, person here. Right? There's a relationship between those. Right? And by the way, person is comparable. Right? Why? Because this person comes before that person when we wrote it out. Right? Book has an author, and you can get the author. That's what those relationships are. Right? Those are aggregate relationships. Again, all technical details that we're not going to really get into. Right? Instead, you're going to use a tool to generate your final UML diagram. But your draft should look something like that. Right? Don't give me 3 pages of text saying, I'm going to do this class, and this is why, blah, 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 blah. Right? Your text should be as terse as possible, and it should focus not on the what. The diagram is the what. Your text should focus on the why. Why are you doing this? Right? And the why is because, well, I created this table because back in the introduction, the client wants this feature, and it supports that feature. That's what belongs in the text. Okay? All right. Questions on design document for this Friday? Yeah.
Is there necessarily like, I mean, with English classes, there's always like a page limit or something. Is there like?
Oh God. Usually there's a page limit or there's a minimum.
Minimum, I should.
Yeah. There should be a page limit here. If you have by the end of the semester, if you have more than 10 pages, you're doing something wrong.
Okay.
Not only that, but that 10 pages includes the formatter. That's the title page. That's the blank page that's always between the title page and the content. That's the table of contents. That's the bibliography. Your content is probably 4 or 5 pages, and a lot of that is going to be diagrams, right? So no, you should not. This is why we talk about reverse outlining, because at some point you're probably going to do that and realize I've written 10 paragraphs here and I'm just rambling, or I've repeated everything that's already in the diagram. I need to cut. We don't want to read that. Nobody wants to read that. Nobody wants to read technical design documents, right? That's why you have to make them short and to the point. Right? But otherwise, again, everything is available on Canvas. Through Canvas, you can get to these. That's not it. That's our assignments, design doc. Right? There is the handout telling you exactly what to do. Right? And there's the Word template right there. If you are interested in the LaTeX template, it's right here, along with a BibTeX bibliography. Oh yeah, BibTeX bibliography. Right? My son, who's in high school, just had to go through an entire exercise for his writing class of properly citations, properly creating citations for AMA style or APA style or MLA style. And why? Yeah. Use a tool to do that, right? And the tool for LaTeX is BibTeX. All you have to do is put these things into annotations like this, and then it generates the bibliography automatically for you. So here's what the template looks like, right? Project title, that's what we're talking about for the first draft. You need to fill this stuff in. You're not Joe Student, you are you, right? And then more pages down here. There, right? It just this bibliography was automatically generated based on that that bibliography that I just showed you. Right? If you choose to use Word though, then the template is right here. I don't know if it'll render. No, it's not going to render on GitHub, but download it and you've got access to MS Word. Right? Anybody want to learn LaTeX? Oh, yeah, okay. So then, yeah, I would recommend using this. Very very little math is going to be in this project, so it's a good idea to learn how to, just create textual documents, right? All right. So, questions? Yeah.
Is it possible to show us how to get into the template?
What do you mean? Like the Word template or the LaTeX template?
Just into the campus one.
Oh, Campus Wire? Oh, you should be in there. You were invited in the first week. We can talk about that in lab, though. All right. Okay. Oh, and by the way, if you are going to use LaTeX, you either have to install everything yourself, or you can go to overleaf.com. Is it? Yeah. Sign in with Google. Yes, that's correct. Whatever. All right. And looks like I've got some stuff in there already. Are there templates? There we go. Journal article? There we go. I don't know what that is. Yeah, there's a journal article right there. Let's see, view source. It looks something like that, but you can get started. You could just import our template and start using that. I'm sure that this is way more complicated than it needs to be for this course. But you can do, the point I wanted to show is that you don't need to install anything for LaTeX. You can just go ahead and get started. And in the browser, basically. You're editing stuff over here, and then it renders over here, and you can download the PDF or whatever. But Overleaf is a LaTeX editor and compiler on in the browser. Okay. All right. So back to actual content here. How much time do we have? Yeah, we have enough time. Let's review what we've done so far as object-oriented programming goes. We've gone through now several different demonstrations on creating classes. You have getters. You have setters that you should generally avoid. You have constructors, and that'll be the focus of the lab this week. You have the 4 pillars: abstraction, encapsulation, inheritance, and polymorphism. Remember that abstraction was a form of information hiding, that it relieves you of the need to knowing the details of an object, how it works, how it gets represented, right? and it's just inside the object, and you just use the object. The quintessential example here is local date. How does it work, right? 3 integers, an ISO string. Ultimately, who cares? Because it just it's representing a concept, and I just want to deal with that concept. Right? Encapsulation is usually comprised of the grouping of data that act on one logical unit. In other words, I've grouped all this data here together. The protection of that data by making everything private and controlling access through getters and or setters. Right? And then the grouping of methods that act on that behavior. And we saw that with the isotope demo, right? That we created this decay function, right? Where's the decay? There, the decay function. It's because the isotope is responsible for knowing how it decays, right? We shouldn't be responsible for isotope things. The isotope class should be responsible for isotope things. Just keep repeating yourself, right? Bank stuff belongs in the bank class. Person stuff belongs in the person class, right? Et cetera, et cetera. Anytime you're thinking, what is this? What is this doing, right? Keep that in your mind. Where should it be? It should be over there. Right? Good abstraction and encapsulation work together to make code more isolated, for code reuse, and to reduce side effects. Right? Side effects are unintended changes to other data in your code. Make sure that your modeling is correct. Is a person a string? No. Is an address a string? No. Right? Those sound like classes to me, because an address is a street, city, state, zip. Right? At least 4 things. Anytime you find yourself 2 or more things, that's probably a class. Right? Now let's talk about inheritance. Okay? Inheritance is something you've probably not seen before unless you've done these other 2 things. Every language has those things. Right? Inheritance is code reuse on steroids. Right? It allows you to reuse a class by extending it, or this is not correct grammar, but extends is the key word in Java, so extensing it to and creating a subclass. Right? This is going to give you a superclass-subclass relationship, which we call is a relationship. Right? The subclass is an instance of the superclass. Okay. Alternative, you can look at this as a parent-child, because we'll generally draw them as the superclass and then the subclass. This is the parent class, and then this is the child class, just like in a family tree, right? Ancestors up here and descendants down here. Okay. So basically, what you do is here's the pattern that you follow, right? That common functionality is located in the superclass, and then it's shared among all the subclasses. Then specific functionality is overridden in the subclass. The quintessential or classic example is an animal, a dog, and a cat. What are the relationships between those 3 ideas? Remember, always think is a relationship. So is a dog a cat? A dog is a cat? No. Is a cat a dog? No. But what is a dog? It is an animal. A cat is an animal, right? So what's the superclass in this concept? Animal, right? What about cat and dog? They are subclasses, right? All animals eat, but the dog eats dog food and the cat eats cat food. They eat whatever they want, right? The other classic example is all animals speak, right? But a dog barks and a cat meows, right? All right, so that will be how we're going to approach a lot of stuff. Just with the rest of our time today, what I want to do is I want to go back to our person class. Right? And it has a lot of things, first name, last name. Of course, you can incorporate maybe an address, private string address. Wait a second, is an address a string? Nope. So it's going to be a street, private string, state, private string, city. I need city first, I guess, right? City, state, zip. City, state, zip, and maybe a country, right? We won't go that far though. Bad modeling. What should I be doing? Putting this into another class, right? What kind of a class? What would you call that class? Address. Okay. And so I'll put that stuff over here. Oops. I'll put all of that stuff over here and put in a to-do. Finish this class, right? For now, though, I can go ahead and get rid of it and say that this is an address. Address. In fact, I'll leave that address class up to you because it's part of your project. Okay? So there's an address. All right, what else could a person have? Maybe an identifier, private, int, ID, right? Something like that. Right? That's good enough. It's more than a first name and a last name. You could get really fancy and do a bunch more stuff. Right? I'm not going to do that. Instead, I'm going to think about what kind of persons are there. You know, this book class over here, a person was an author. What if I were to create an author class? Right? New class, author. Right? Well, now what is an author? Yeah, it's a type of person, so maybe I should take all of this stuff and repeat it over here in this class. Because an author has an ID, a first name, a last name, and address. What principle have I just violated? The DRY principle? Don't repeat yourself. So I'm going to go ahead and get rid of all this stuff. And I'm going to say that I extends person. Okay? Now it's giving me an error here because I need to have at least a constructor here. If you remember I said that super, you can ignore it for now. Now you can't ignore it. What is super referring to? The superclass, person. We've got an author down here that extends the person class. An author is a person, right? Just like a dog is an animal. And so we need a way of constructing this person using their first name and last name. We'll take a first name and a last name and pass it up to the super constructor here. Now, it's kind of useless just to have an author extending a person if we don't have additional behavior, right? Or additional state. Right? What I'm going to do is I'm going to create a list of books that they've written. Author books is equal to new. Actually, I'll leave it like that for a second here, and we'll do it down here. Actually, I'm going to bring this in first, and let's talk about it before we go further. Do you remember that map that we created where we had the author, and it mapped to, oh, wow. All right, 1 second. We've got enough time left that I need to plug in. Looks like I didn't. I'm surprised that it's let me go this long without throttling. It probably is in the background and we're like a minute behind on the stream. There we go. All right, fixed. All right, so you remember that map we used to map an author to their list of books? Right? That was a very useful idiom, or that was a very useful technique for creating a report like that. This is the same idea, but it's more object-oriented. Right? We can now have the list of books inside of the author class. Why didn't I do that before in the person class? Right? Is a person necessarily an author? No, not unless they've written a book. Right? And there are plenty of people that have never written a book. Unfortunately, there are plenty of people who have never read a book. Right? So that seems more like an author thing to me. Repeat that mantra. X things belong in the X class. Somebody's list of books, that's an author thing to me. That belongs in the author class. Right? So what about my getters and setters and anything else here? Guess what? They're all inherited. They're inherited from your parent. This is why we call it the parent-child relationship. Do I need to have a get last name over here? No, in fact, I can't because this last name is not visible to the subclass. We'll talk about that later. Right? Instead, let me go, do I have a demo? I don't have a demo class. Let's go ahead and create a demo class. New demo class. And I want a main. Right? There we go. All right, so I can create an author. A is equal to new author. Jane Eyre. Eyre? I don't know how you spell it. There we go. There's Jane Eyre. All right. And do I have access to her toString method? System.out.println a.toString. I do. And it will call Eric, comma Jane, right? And do I have access to her get first name or get last name or whatever else it is? System.out.println a.get last name. I do. Right? Do you see this method, this get last name method over here in the author class at all? No. It's up here in the person class, which is the super class of this author class. It inherits everything, so you don't have to repeat yourself. Right? I do want a way to get books into this class though. So what I'll do is I'll create another method here, public void add book, right? Book B. Right? And the way that the purpose of this function is that I'm going to add this .authorbooks.add B. So that I can create a book by Jane Eyre and then add it to her collection inside of that class. Right? Let me come back over here to demo and create that book. Book B equals new book. She wrote. Wait, am I misremembering? Who wrote Pride and Prejudice? Pride and Prejudice. Not the various movies. Jane Austen. Darn it, not Jane Eyre. All right, let's go ahead and go with that then. Jane Austen. And her book is Pride and Prejudice. There. Except I don't have a constructor like that, so but I'm going to have to pull all this other stuff. Except that I'm going to create another constructor here, just really, really quickly. String title by person, just to make it simple. This dot title is equal to title. There. So I'm going to create this book over here by Jane Eyre. Pride and Prejudice by Jane Eyre. Okay? All right, now let's go ahead and try to get her books. Dot get books. I want to print out all of her books. Okay. Do I have a get books method here? No. Should that go in the person class? I don't see any books here. That's something that's different from the superclass that distinguishes itself. A dog barks, a cat meows. Right? So we need a way of distinguishing ourselves here as well. Public list of books, get books. Return this dot author books. And now I do have that method here. Okay. Let me show you the difference. What if I just created a random person here? Right? Joe, new person, Joe Schmo. Right? Does he have a toString method? Indeed. Right? Because that's in the person class, and Joe Schmo is a person. Oh, sorry. Get books. I never called add book, and I never instantiated it. Darn it. All right, let's do it. This dot author books is equal to new array list of books. And let me bring that in. Import that. Right. It's not compiling. That's because it's having an existential crisis. Right? Remember, we're creating an author. Does the author exist as of line 11? We're in the middle of the constructor. It's constructing itself, like a building, like an automated building that constructs itself somehow, right? While it's constructing it, does the building exist? No, only after it's done constructing it. In other words, down at the end, does it exist? Right? Likewise, what about the person aspect to it, the superclass? Does it exist yet before we call the super constructor? Nope. So that has to be the first thing that you do. Right? If you're going to call a super constructor, it's got to be the first thing you do. Right? And then you can go and do whatever you want with it. Right? And I never added her book either, right? So a.add book B. And now it'll print out that she wrote Pride and Prejudice. Right? Okay. All right, now back to Joe Schmo here. Does he have a toString method? Yes, because it is defined in the superclass. But does Joe Schmo here have books? P. Is that a person thing? Nope, that's an author thing, right? And Joe Schmo here is not an author, he's just a person, right? Just like a generic animal, okay? So I'm going to go ahead and get rid of this. To set us up for next time, I want to create one more class. What other kind of people are there? Creative types. I think movies.
Painter.
Okay, we could go painter. Right. Let's do that then. New. Actually, no, because I don't know any painters.
Director.
Okay, there we go. I know directors. Right. Director. There we go. Right. Well, a director is a person, so we should extend person. Okay. And then here too, we need to add a constructor. What distinguishes a director from an author? A director doesn't have a list of books. A director has a what? Author or director of movies or films. There we go. That would require me creating a film class. For now, I'm just going to go ahead and treat it as strings, though. The title of the film. Okay. So this dot films is equal to new array list of strings. Right? And keep it simple for now. Right? And import that. And then we would have the same boilerplate kind of stuff over here. Add books, instead of books, we would have film, and then string F for the film. This dot films, add film, there we go. Get films, and that's a string, and that's the films. For as much as I had to change, I didn't even need to copy pasta it. All right, but now we've got a conundrum over here, okay? And this is what we're going to solve next time. What about Stephen King? We all know who Stephen King is, right? Who is he? He's an author, right? But little did you know that he's also a director. In fact, I just watched it yesterday. Do you know what Stephen King directed? Maximum Overdrive? Right. All right, so if you've never seen that film, it's generous to call it a film. If you've never seen that movie, right, then you probably need to watch it. You can watch it on like Pluto TV or something for free. And it's a terrible 80s film with a horror film about all the trucks become alive and start killing killing humanity, right? All because of a comet, an alien comet that's it's eventually destroyed. But sorry for the spoilers. But so Stephen King here thought he was an author. He is an author, but he thought he was a director, and not a good one. But he's both, right? How do we do that? Yeah. So that's what we're going to solve next time. Okay. So we'll learn that inheritance is a good thing because we've got some benefits here. We're also going to learn that it's a double-edged sword, that sometimes it doesn't make sense. All right, I'll meet you up in lab. Questions? Yeah.